Welcome everyone. My name is Alberto, and welcome to the first workshop that we're just starting. This is the first one. I'm super excited to host this one. And the idea of the workshop is to provide an environment, more focused on developers and bring guests in the future workshops I will have. So for this workshop, what we've prepared is just like an intro presentation, to help developers get started on Moonbeam. So yeah, thanks again for being here, and let's just, I guess, jump right to it. So I'm gonna share my screen. And yeah, so the idea of the workshop is it's gonna be like a more informal presentation, right? So feel free to ask questions, interrupt in the chat, and ask questions in the chat. If you're new to Crowdcast, you will see an ask question button. I know that we have 3 questions right now, so I'll get to them once I start the presentation. But it's a more informal presentation, so feel free to ask questions. I'll stop, answer questions, and I want it to be more interactive rather than just like a formal presentation. So once again, thanks for tuning in, and let's get started. So yeah, the title of this workshop is to how to get started with Moonbeam. Like I mentioned before, my name is Alberto, and I'm the Developer Relations Manager at PureStake, which is the company working on Moonbeam. So as in session structure, this will feel similar in some ways to the other presentations that I've done in the past, but we're going to touch different topics. But I mean, the session structure will feel similar as well. So we're going to do a brief introduction into Moonbeam, just basically a basic summary. I really like when the presentations are self-contained. And then we're going to go and discuss and talk about technical bits. We're going to talk about Ethereum compatibility and other features. Oh, and before I forget, I shared a repo, a link to a repo. And in the repo, you will find the link to the presentation, all right? And last but not least, we're going to have a short demo. So, well, actually not a short demo. Actually, the longest time allocation of the presentation will be on the demo. So it's just going to be 3 very different, 3 topics, and we're going to focus more on the demo at the end of the presentation. All right, well, let's just get started, I guess. So what is Moonbeam? And Moonbeam is just a smart contract parachain on Polkadot. So if you're not familiar with the Polkadot ecosystem, Polkadot, it's what it's called a relay chain. And they're like blockchains that attach to that relay chain that it's Polkadot, right? So Polkadot does not offer smart contract capabilities. So basically it leaves this feature to these blockchains that connect to it. And one of these parachains or blockchains will be Moonbeam. So, and we like to say that we're the easiest entry point to the Polkadot ecosystem. And why do we say that? Because we provide support for a Web3 compatible API, and we have an EVM. So existing projects and developers from the Ethereum ecosystem can just port and start working on Polkadot with minimal effort through Moonbeam, right? And we also like to say that we provide developers so they can use the tools that they know and love already in the Ethereum ecosystem. They can use the same tools on Polkadot through Moonbeam. So this means that these tools, they've been working with them for years already, right? So the idea is that they bring all that knowledge and that experience and start working with these tools on Polkadot through Moonbeam. And Moonbeam offers a more complete features that extends just beyond smart contracts, right? So we have modified the underlying account system so that it's all Ethereum, and you're going to sign everything with your Ethereum account. And we also have some other exciting features like event subscriptions and more features that we're working on right now that we should have news for you guys soon. So it's super exciting to share this with you. I'm going to stop in this slide and ask some of the questions that they're related to the network, so that's why I want to answer them here. So the first question from Syed Montaz, it's does Moomi require Oracle services for its network to operate efficiently? So this is a good question. Oracle services are providers or services that inject real-world information, real-world data into the blockchain, right? I guess one of the most famous one that you probably know is Chainlink, and we do have a partnership with them. And what they do is that they connect this off-chain, what is called off-chain information, and then inject that information to Moonbeam via smart contracts. So I wouldn't say that oracles actually make the network work more efficiently or not. They just provide added features, right? Because there are a lot of services that need this kind of like data that is located off chain. For example, if you want to build a betting application on Moonbeam, you would need score data, right? And you cannot get that on chain, so you need an Oracle provider such as Chainlink to inject that data for you on chain, right? So yeah, we don't have any airdrops planned. I'm gonna share the foundation, the Moonbeam Foundation link at the end of the presentation, and you will find all the details there regarding the the tokens that we have, which are River for our Kusama deployment called Moon River, and then Glimmer for the Moonbeam deployment in Polkadot called Moonbeam. This is a great question. Will Glimmer token be required to launch contracts? What kind of gas fees should we expect to pay to launch? So the tokens that we will have in our ecosystem are what it's known as utility tokens. So when you're actually working with smart contracts, basically each action that smart contract does, it's translated into something that is called an opcode. All right, so an opcode is basically an instruction. Let's say I want to add 2 numbers. That's an opcode. Every opcode, every instruction costs gas, right? And at a core level right now in our testnet and in Ethereum, the gas of these interactions is the same. But will not be the same is the gas price. So the amount of tokens or ETH or Glimmer or DEF in our testnet that you pay for each gas unit. So currently our testnet has a transaction limit per block of 15 million gas, which is a little bit higher than Ethereum. Ethereum is currently around 12 million gas. And so we're talking about that we have more gas allocation per block than Ethereum. But we also have, theoretically, we'll have half the block time. So Ethereum block time is around 12 or 14 seconds, and Moonbeam block time will be 6 seconds. So we do think that we'll have a cheaper platform for contracts to be deployed, but we're still, we haven't run any numbers or benchmarks currently that I cannot share with you. So yeah. So regarding the crowd loan participation, there's no details regarding the Moonbeam Foundation, so everything will be shared via the Moonbeam Foundation website. So like I mentioned, I will share this foundation URL at the end, but I noticed that Kathy, who is joining me in the chat, is sharing already some great links for you guys. So yeah. All right, let's continue. Thanks a lot for the questions. I really like when there's a lot of interaction. So Moonbeam, we see Moonbeam as a multi-chain in Polkadot, and we think so because let's say you have your Solidity smart contracts here, and you can actually deploy these smart contracts to Ethereum, but basically by doing very, very minimal changes, and not even to the contracts themselves, but the way you deploy the contracts, you can just send them to Moonbeam, right? So if this is a Polkadot ecosystem with all of these blockchains, which are called parachains, Moonbeam will be one of them. And the great thing about deploying contracts to Moonbeam is that it provides access to the whole Polkadot ecosystem. So your contract will not only live in Moonbeam, but you will be able to interact with other assets that will live in other blockchains or parachains. So that's one of the key benefits of accessing Polkadot through Moonbeam. And we have a bunch of projects already deploying with us, and I think that this is one of the core things we are building, a lot of great partnerships. And some examples include SushiSwap, Human Protocol, Ocean Protocol, and others that I'm not going to mention, but they're listed there. And we do have a great website when we list all our core partnerships, so you can go and check it out. And the cool thing about deploying contracts with Moonbeam, like I mentioned, is that, for example, if you're using Truffle as your deployment tool, you can just, when you define the providers, you can just say, hey, instead of deploying to Ethereum, I just want to deploy to Moonbeam. And it's just basically almost like a one-liner. And the cool thing that we've noticed with some of these partners that I've spoken is that they're a little bit intimidated. If you're an Ethereum developer and you're like, I don't really know how to get started with Moonbeam. It's just such a different platform, right? It's like Rust. It's not an Ethereum node. How do I get started? And then when we explain to them, it's just changing the provider URL or anything like that, or something that simple. They get quite surprised. It's like, hey man, I just grab my contracts and deploy them in less than 5 minutes, 10 minutes, whatever. And it was just so simple that it's basically the beauty that we're building. We want to be the most frictionless platform for like Ethereum in terms of Ethereum compatibility in the Polkadot ecosystem. All right, so I guess the question that I just mentioned before, like right now, is that how do we bring Ethereum compatibility to a substrate-based chain? And Moonbeam is built using the framework called Substrate that is based on Rust. So it's another totally different programming language. So how can we bring Ethereum compatibility features to a substrate-based chain? And before I go into this topic, I want to explain some simple things that help me really understand, what's the benefit of Moonbeam. So this is called ETH. I just called it ETH Json Rpc. So Json Rpc is a protocol to communicate. It's an RPC protocol where the payload is a JSON object, right? So the idea is that when you're an Ethereum user or developer, that you're using these tools such as Metamask, Truffle, Remix, Hardhat, the Web3 JavaScript library, Etherjs, and all this. Those are wrapper functions or interfaces or layers of abstraction that help you basically interact with an Ethereum node in a very easy way, right? So, but what's happening underneath is that all these tools, what they do is that build this JSON RPC messages and they send them to an Ethereum node via like a request thing, right? And then the Ethereum node answers or responds to that request with the data that you ask. So for example, when Metamask is telling you the balance that you see there, what's going on is that Metamask is asking via probably the Web3 library, hey, I want to know the balance of this person. And then the Ethereum node says, there you go, here's the balance. And then Metamask just displays it in a very nice and neat way, right? So this is what's going on basically when you're interacting with Ethereum node. So how does this work in Moonbeam? And the first definition that we're going to talk about is called frontier. And I really like this definition because I'm not like a hugely technical person, and this definition, it's quite nice and quite simple. And the idea is this. So Frontier, it's basically a project by Parity Technologies that we have actually worked with quite closely. And it acts like a middleware between the Ethereum user or developer and the Moonbeam parachain or the Moonbeam blockchain, right? So it's a component that lives inside Moonbeam, but I like to put it in the middle because how I like to think about this is that it's a middleware that translates everything that's going on from the Ethereum user or developer to something that Moonbeam understands, okay? So the idea is that you as a user or developer will do the same thing that you'll be doing in the Ethereum world, and you don't have to really worried about what's going on, right? And then Frontier will take care of you and translate all that information into Moonbeam, right? So we have a question. So Gary Crawford asks, what's the barrier to entry for running a node? Is it open and easy like with Ethereum, or require much higher standards like some DPoS systems? Is there a need if Moonbeam gets the security from Polkadot? And what incentives are there to run? So yeah, this is a really great question, and it's quite a complicated one. So I'll try to drill it down into the different questions that are inside that question, right? So basically, we do provide two ways of running a node right now in the testnet. So we do have a testnet called Moonbase Alpha, and I would say that we provided the easy way to run a node and the hard way to run a node. The easy way is just to run a Docker container, and it's almost a one-liner. It's almost copy and paste, and if you have Docker installed, then you need a little bit of understand how Docker works. Not really, but it's better if you do because it's a lot easier. And then with that one-liner, you will have a full node running, so you can access your own private endpoints, right, and interact with that node. We do provide in our testnet an open access node. There's no API key or anything, so you can actually interact with that node if you're interested in sending contracts or anything. So the requirements, I would say they're, it really depends, right? So right now in our testnet, the load is not incredibly high. So we do have a load on the testnet, but it's not incredibly high. So right now you can run a node with a very simple machine. But as the network grows and we'll get more much higher loads in the testnet, the machine needs to have higher minimum specs, right? So we do in our documentation side, we do have a link and a table with the minimum required specs to running a node. Yeah. Okay. So I mean, remember that the question was Marcus answered. I want to go back and finish it. I got it. So, is there a need if Moonbeam gets its security from Polkadot? So yeah, I mean, this is a very good question as well. So remember that Polkadot uses this hybrid consensus mechanism, right? So you have the parachains will actually produce the blocks, and then the relay chain will verify that the state transition between two blocks, it's okay. So basically the state transition is let's say in very simple terms, if in the previous block, Alice had 10 and she made a transfer of 1 to Bob, in the next block, then Bob should have 1 and Alice should have 9, right? More or less, in very simple terms. So if that state transition is valid, then Polkadot will say this block is valid. But this doesn't mean that at a parachain level you need a security mechanism because you need collators or block producers to produce blocks, right? So we do provide, Moonbeam will have incentivization in terms of like rewards for the block producers or the collators, and staking rewards for the nominators, which basically stake their token holdings behind a collator. So it's very similar how you stake right now for relay nodes on the Polkadot mainnet. We're still working on the details right now, but basically everything will be released and you will be informed and you will have tutorials on how to do it as always. So yeah, Gary, thanks a lot. It was a very long question, but hopefully I got everything. All right, I'm gonna continue and then I'll go back to the questions, all right? So we got more or less clear on what Frontier is. So let's go into like a little bit more complex definitions about Frontier, right? It's not too complicated, but just bear with me right now. So on the left-hand side, we have the Ethereum Json Rpc that I mentioned before, or like, tools like Truffle, Hardhat, or libraries like Web3.js or Etherjs, right? And what they will do is that they'll interact with the Frontier RPC extension. And they're going to send the regular Ethereum Json Rpc methods, like I mentioned before. And then the Frontier RPC extension basically provides like a Web3 JavaScript or any other compatible API, and it will map this calls to something that it's understood by Substrate. So this is what I mentioned before, that it's like a translator, like a middleware, right? It's going to map something that it receives, and it kind of quite doesn't understand, like Substrate doesn't really understand this, and it's going to tell Substrate, hey, this is what you need to do. The Pallet Ethereum that it works together with Frontier, basically it's used to emulate Ethereum blocks, okay? So in our blocks, in our Substrate blocks, we have like tiny emulated Ethereum blocks inside. It's just basically because when you're actually requesting information to the Ethereum node, it'll try to fetch it from these emulated Ethereum blocks, right? So that's the main functionality of the Pallet Ethereum. The Pallet EVM is what actually maps it's just what it says on the slide, right? An access layer between the substrate-based runtime and the EVM implementation in Rust. So it's like a translator between the substrate runtime and the EVM that is coded in Rust for this substrate in the substrate framework. But I mean, honestly, I really like to put things on more or less simple terms, right? So what does this mean? So going back to the same definition as before, we have this link that I put on the slide is the ETH wiki for Json RPC's API. So in here, you will see like a very, very long list of all the Json RPC methods that are available, right? And I know that we talked about Json RPC, so what is the Json Rpc payload looks like? So basically, we can grab this curl command here, and what you see in here is the endpoint of our testnet that we have available. So it's the HTTP endpoint of the testnet. And what we're saying is that, hey, this is the payload that I'm sending. It's in Json Rpc 2.0. The ID of the request is 1, meaning that the response should have the same ID. The method is the ETH get balance method. So what we're asking the node here is like, hey, node, I want to get the balance of this account that I'm sharing in the parameters area, right? So in here, I'm telling, hey, I want to know the balance of this account down here. And what I'm including here is just to tell the node that I want it from the latest block that it has available, right? And the response from the node will be, hey, whatever guy who made this request, this is the result of that request that you asked me to provide, right? The data that you asked me to provide. And you can see that the ID is the same as the request ID. And And basically this really weird number here is just hex encoded. So it's a hexadecimal number. And if you translate it to a decimal number, that is something that we understand, it will be this in dev tokens that this was dev in hex. So actually the response won't be in dev, it will be like in way, but this is basically what it translates to. And this is basically what happens in Metamask. So in Metamask, when you see you can see that I did this request for Alice's account and I got this response, and this is basically 99.999.9999 tokens, right? So there's 1,000 dev tokens. And when I understood this, I was like, wow, I mean, this is really interesting, right? It's just like how, at a very more or less low level, how you communicate with an Ethereum node. And what Moomi provides is the same functionality. So this call was made to a Moonbeam node, right? So I mean, for me, this was one of the first ways I really understood the power of Moonbeam. It's just everything will be exactly the same from the developer point of view, but in the guts, it's just basically translating to something that it's understood by substrate. All right, so let me see if there's a couple more questions. This is super exciting to see a lot of questions, really. So will PureSig be extending Metamask to support Glimmer and the Moonbeam network natively? Are there other DApp wallets that support Moonbeam natively? So yeah, this is a really good question. We know that Metamask is working on this like multi-chain environment, and the idea would be, for example, if you go to the Moonbeam network page, you will see a button that will say connect to Moonbeam, and when you click on it, MetaMask will automatically switch and connect to the network that you're clicking there. So right now, MetaMask works with Moonbeam, but you have to add the custom network, and we'll do it in a little bit later on. But yeah, I mean, that's how it works right now. And we do have support for other wallets. Right now, we do have a tutorial on Math Wallet. They added support for our testnet. And I'll be sharing these links later on the presentation. I know there are some other wallets that might work with Moonbeam. So basically, any Ethereum wallet that allows you to add like a custom network should work with Moonbeam. All right. And yeah, and the other question from ETH for Life. Oh, okay. So it was asked in the chat. Will all those layers will see less performance compared to Ethereum? No, actually, no. I mean, right now, like I mentioned before, we currently have a higher gas block per limit. So basically, this is we have 50 million gas per block, and our execution time. So I don't want to go into the very low level details, but the execution time that we have for those 15 million in gas is only 0.5 seconds. So in 0.5 seconds, we're executing everything related to the Ethereum transactions. So that's actually quite high performance. So yeah, you don't have to worry about performance. We'll release the numbers when we have some real benchmarks. But what can I say? What I can say right now is that we have a very short block time of 6. We'll have a very short block time of 6 seconds, and currently the gas limit per block is 15 million. But hopefully we can do further optimizations to increase these in the future. But don't worry, we'll keep you updated. Yeah, no worries. Happy to answer the questions. All right. So unified accounts. What does this matter? Why does this matter? Right. I'm gonna go here a little bit faster because we have spent a little bit more time than I wanted on the slides. But anyways, the idea is that any substrate parachain that adds the EVM palette, the Ethereum palette, and Frontier, as I mentioned before, as I showed you before, can say that it's Ethereum compatible, right? But the problem is that this is how it looks, and it looks complicated, but I'll try to go, block by block. So let's say a user called Alice, and that user wants to interact with the EVM side of things, so with the Ethereum side of things of this blockchain. But she actually needs a private key that it's related to an H160 address. So the H160 address is a regular Ethereum address. So don't get dizzy with all these definitions, right? So with this private key, she can sign messages that will interact with the EVM side of things, right? So the messages need to be signed with a private key that is related to the Ethereum signature scheme. And this private key, public key pair can be mapped to an H256 address. And the H256 address is the one that it's used in Polkadot or in the substrate runtime. So in the substrate side of things, right? But the problem is that this person doesn't have the private key of that address, okay? Because this is not related. I mean, this is mapped to this H256 address, but we don't know the private key of this H256 address. So the person cannot send transactions to the left hand to the substrate runtime. Okay. So in order to do that, that person would need another private key that it's related to an H256 address to sign transactions that interact with the substrate side of things, right? So this, what kind of transactions are we talking about? We're talking about governance, talking about staking. So this is a little bit complicated because one person needs to have at least 2 accounts to interact with the different sides of the blockchain. This means that if you want to stake, we want to have the balance in account 2 in this example. But if we want to interact with the EVM, we have to have the balance in account 1. So it's a little bit confusing, right? So what we did is that we unified the accounts to everything to H160 address and its private key, right? So basically with the same private key, you can sign transactions on both sides of the blockchain, meaning that you will be able to do staking and governance with your own Ethereum address and private key that you might have right now already sitting in Metamask or whatever wallet you use. And we think this is basically beauty and simplicity, right? So with the same key pair address, you will be able to interact with both sides of things, which I think is super exciting. All right, wow, that was a lot of stuff to cover. Let's go for the demo now. I'm gonna drink a little bit of water and let's go for the demo. So in the demo, we're gonna do different topics. Basically, we're gonna cover how you can get started with the local node. We're gonna cover the Docker version of things because it's like a lot easier, honestly. When you build the binary, you actually have to wait like 30 minutes, 40 minutes, depending on your computer. So the Docker thing is like super, super simple. We're gonna go to Metamask and connect our local node to Metamask, and we're gonna interact with it. We're gonna go to the Remix IDE, and we're gonna deploy some contracts. We're gonna play around with some Ethereum JavaScript libraries, such as Web3 and Etherjs, and Truffle and Hardhat as well. But everything that you can find, everything that we'll cover in this presentation, it's in our docs website. So let me show you the docs website really quick. So basically, this is like the one-stop shop for everything we just talked. We're actually working right now on like rearranging everything and making the journey for the developer a much like nicer experience because it has grown quite a bit. So right now it might be a little bit confusing. So, I mean, we have tutorials on different integrations that we have done. We have a getting started guide, how you can get started with the local node or the testnet. So everything that you need, you will find it here, okay? So another thing I wanted to point out is this Moomi presentations repo that I shared before. So the idea is that in here, you will find as different branches, the different presentations that we've done right now, for example, the workshop 1 or in the past. So if you go to the main branch, you will see how you can get this content yourself. You can play around locally and replay the video and go along with me, trying it yourself. So right now we're in the workshop 1, okay? All right, so the first thing I'm gonna do, I have this terminal prepared for you guys. And what I'm gonna do is, let me expand this a little bit. And I just basically cloned the repo that I just showed you guys. And we're going to start with the Docker instance, okay? So in here, what I just did is I just put the Docker command that you need to run to get started with a local Moonbeam node. It is just that simple. It's almost copy and paste. You just need to have Docker installed in your machine. Of course, I'm running in Ubuntu right now, so you'll need to adapt this for your own specific use case. So what I'm doing is that I'm going to Docker run this container right here, this Docker image that is called the tutorial v6. Currently, this is not what it says on the docs website, but I'll work on updating the docs website probably next week, so you have the same tutorial as there as well. And I've used different flags. So basically, the --dev flag, it's going to tell the Docker image or container that will run that this is a standalone node. I've also added, but this is only for my applications. I added these 2 flags because I want to use different RPC and WebSocket ports, okay? Because I'm running in a shared machine. So basically, I don't want to like collude with my colleagues that might be running nodes on these ports, right? So I just said RPC port 9937. This means that I have to connect to this 9937 port for RPC stuff. I also added this because remember that I was explaining to you guys the JSON RPC stuff. with the RPC trace, we'll be able to see this kind of things on the terminal. Hopefully it's not too confusing, but we'll see if we can give it a shot. And the node telemetry flag is because we're running a standalone node, so we just prevent, there's an error that is saying that telemetry was not successful. With the node telemetry flag, it'll just, just telemetry features are disabled. I left some more stuff in here for you guys to see. The ceiling flag is quite interesting because when we run a node in --dev, we're basically doing what is called instant sealing. That it's similar to Ganache nodes on Ethereum. So in instant sealing, a block will be produced every time there is a transaction. So it's not like I'll produce a block every 12 seconds or 6 seconds. I'll just produce a block when I receive a transaction. And it's a lot faster when you're doing development. So it's a pretty nice feature. But let's say for your applications, you want to have a block being produced every X amount of seconds. So you can just use the ceiling flag, providing the time in milliseconds, all right? All right, so what I'll do is just copy this command in my terminal, and it's like magic. You will see your node start, popping up some messages. What we'll see right now is that we have 0 blocks being produced, right? Like I mentioned, a block will be produced every time I run a transaction, right? All right, so for the next step, it's just as simple. That's it. We have a standalone run running where we can do all the tests that we want. And it's just like almost like a one-liner, right? So the next stuff I want to show you, it's Metamask, okay? So let's say I have Metamask connected to the testnet, or let's say I have it on Ethereum mainnet, okay? And this would be really nice, right? Basically, what's going to happen is that if I change to Moonbase Alpha, you will see that I have my standalone account with this amount of tokens, all right? But let's say I want to connect to the standalone node, all right? In order to do so, you have to go to the top right corner, and this answers the question regarding the wallets that someone was asking, right? So go to the top right corner and go to Settings, and then go to Networks, and then click it Add Network. When you do so, you'll see this field right here that you have to fill in with the information that you want, right? So in my case, when you go to the documentation website and you go to local node using MetaMask, you will see the information there. And if you want to interact with the testnet, you can go to testnet, integrate MetaMask, right? And in here, you'll see all the tutorials and information that you need to get connected to the Moonbase Alpha testnet, okay? So in my case, I'm going to go using MetaMask. You have a nice video there, and then also a step-by-step of how you can do it. So I already did that, and I have this standalone node here. You can see I added my 9937, so my custom port, and I just put a name there, a token name, and the chain ID, and then I can connect to the Moonbeam standalone node. All right. And basically, the Moonbeam standalone node offers an account that has all the funds allocated to a single account. In order to import that, if you go to the tutorial, you will see the private key. Please note that this private key is public, so don't use it, as your account or anything, because it might just create problems, right? So in this case, what you can do is just copy this private key and then go into this into this top right corner button and click an import account, and then they just paste the private key here. I already did this. So you can see that I have already this account imported, and I have all the funds here, right? So now I can just send some funds. I can just send, transfer, Alice. I'll just send, okay, so yeah, I'm gonna send transfer Alice. I'm gonna send 100 dev tokens. And because this is a test net, you can put 0 in gas price. Of course, this will not be the case in the future. But then when you click next and then confirm the transaction, you will see that basically Alice should get the 100 dev tokens. Sometimes this might happen, right? Sometimes you will see that the transaction is pending and it's not working. And the problem is that because MetaMask actually stores the nonce value locally. So if you're interacting with this account with other tools like the Web3 library, this will actually increase the nonce of the account, but MetaMask will still have stored that old nonce value. To reset that, you can go ahead into settings and then advanced and reset account. This is something that I use quite commonly when I'm developing because the nonce value might be wrong here. So now that we have the transaction confirmed, I can go to Alice and we can check that this is, we get 100 dev tokens, right? So great, I mean, we just transfer money using Metamask in the standalone node. So regarding Remix, let me reload the page. Basically Remix, it's I don't know if there's any questions. Yeah, so I mean, like Kathy mentioned, the stream is being recorded and you can find it with the same link. You can find this recording later on. And it'll be great because, you have the repository and you can follow and tag along with these tutorials, yourself. Basically, what we have here is that I'm gonna deploy this contract, this Hello World contract, in the standalone node that I'm running. Okay. So if you're new to Remix, what you have to do is just when you go into the remix.ethereum.org website, click in here in the Solidity, and this will install the compiler and the deploy and runs transactions tab. In here, what we're going to do is that we're going to deploy this Hello World contract. It's very, very simple. I just defined the Hello World contract. I'm going to store a string. I'll make it public so I can fetch the value of that variable, and I'll just name it text. And then in the constructor function, I'm going to set that text string to hello world. All right. So I'm going to go ahead and compile this contract. I usually use the autocompile feature because it's just like nicer to have the contract autocompile. And then when I go to deploy and runs transactions tab, I have to make sure that I click here on injected Web3. Okay. And you will see the chain ID here popping up just below that box. You can see that I have Alice selected, and I can just go ahead and deploy the contract. Once I do that, MetaMask will tell me, hey, are you sure you want to sign this transaction? I'll just click confirm. And because we have instant seal, you will see immediately the transaction being confirmed down here, and I can see my contract under the deploys contracts tab. All right, and then I can just fetch the word. Once again, this is exactly the same case if you would do it on the Moonbase Alpha testnet, okay? So the only difference would be that you need MetaMask to be connected to the Moonbase Alpha testnet. So there are very similar examples, just basically setting up MetaMask a little bit different. All right. I'm gonna jump the next tutorial because we don't have a lot of time. Make sure to ask any questions if you have any on the chat or in the ask a question box. So for the next tutorial, what I'm going to do is that I'm going to make a transaction using the Web3 JavaScript library. Okay, so this is once again in the repository that I shared. What I'm doing here is that I already did npm installed on the repo, and I have the Web3 library. And basically, I imported the private key that I'm going to use in this secret stuff.json file. So right now I'm using the Genesis account, so the one that has all the funds. So this is that private key. And what I'm doing down here is defining the Web3 instance by providing the endpoint that I want this to connect to. Once again, note that I have the 7 here. So this is my custom network that I'm running in my machine. If you want to deploy this to Moonbase Alpha, you can just use the RPC endpoint that we provide, and it's in our website. Okay, it is that simple. And if you want to do it in an Ethereum account, you can just here add another Web3, and then here provide the Infura API key, Infura API, right? And then you will just have your Ethereum provider in here. So now down here in the deploy function, what we have is we're going to use the Web3 instance that we created and use the ETH accounts sign transaction method, where we pass in the transaction object. In this case, we're going to transfer to a variable called address2 that I've let me put this down a little bit. We have defined address2 as Alice, and this is the Genesis account. The value that we're going to send is actually 100 ETH. So let's put 150 just to change it a little bit. And we're using the Web3 utils to way function because at a contract level you always speak in way. So way is a small, because contracts cannot use decimals. You have to speak in the smallest unit available, that it's way. So we have to transform everything that we need into way. So MetaMask actually, when it's just showing us ETH, but actually when MetaMask requests the balance of that account to the node, the answer it'll get it's in way. Okay. this is the gas that will be used in this transaction, and then I'm signing the transaction with the private key that I imported from this file. And then we're going to use the Web3 ETH send sign transaction method by passing the raw transaction object of this create transaction variable. And I just put some logging just because it looks nice. So I can just go ahead and do node 01 transaction. And you will see that this looks like super fast because I have the instant seal feature, right? So I have from to, and this is a transaction hash. What I'm going to do is that we have Moonbeam TestNet Explorer. This is actually based on the Expedition Explorer that one of our ambassadors, Alejandro, I think he's in the presentation, he reskinned to the Moonbeam colors. And basically in this Explorer, you can actually go ahead in these configurations and then set here the Moonbeam RPC. So basically that way it is connected to the testnet. And in here I can just paste this transaction hash, and you will see that that I have here the information regarding that transaction, right? The from, the to, the amount, and all that. Yeah, this is I just saw a question by ETH for Life. This is a good question, and it does work seamlessly, and we'll see that example like in 10 minutes, hopefully. So yeah, it's exciting to see that we work with the HE wallet provider. All right, so you can see that I just sent 150 ETH from the Genesis account to Alice, and we can go ahead and check in Metamask, right? If we have 250 DEF now. Great. So the next example is Etherjs Library. So Etherjs is another wrapper library in JavaScript that just basically provides really simple functions that underneath what it's doing, it's sending Json Rpc stuff, right? So in this example, what we're going to do is we're going to deploy a contract using Etherjs. And you can see that I'm importing the library. I'm importing the contract stuff. That's how it was named. And basically in here, what we have is the bytecode and the API of the contract. And then once again, I'm setting the provider URL to my local standalone node that I have. And you can see that I have a 7 here. And as before, you can just deploy this to Moonbase Alpha or any Ethereum testnet with an API, for example, from Infura. What we're doing here is defining the provider with Etherjs and a wallet. So, I mean, Etherjs works a little bit different. It has a wallet as a signer. And as you can see down here, when we're creating a contract instance. So we're using the Ethers contract factory where we pass in the ABI, the bytecode, and the wallet. So this is a contract instance that has already like a signer. And then down here on line 22, we can deploy this contract by calling the deploy method. So we don't have to pass in the private key or anything because that is already included in this instance. And what we're doing here is passing the parameters of the constructor function, okay? So this is an incrementer contract that I'll show you in a little bit. And then down here, we're just waiting for the contract to be deployed. All right, and that's it. I mean, it's just a very simple script that you can test in Ethereum and Moonbeam or whatever. And I can just go ahead and run it with Node. And you can see that I have attempting deploying from account blah, and this is the contract address, right? If I go to Remix right now, and I do have this contract here, it's called Incrementer. So basically this contract, you can actually just go ahead into the deploy and runs transaction tab and just paste in the address of the contract here. And because Remix has the ABI of the contract, we will actually get an instance of the contract that we deploy down here. So you can see that I can fetch the number, which is currently 5, that we defined in the constructor right here. But we can also increment the number by 10 and run this transaction, sign it with Metamask. All right, and now that it has been confirmed, I can just see that this number that I was storing was incremented by the value that I passed in, okay? And I can reset this number to 0 by running the reset function. It's super fast. Like this is what I really like about this instant seal feature, that usually you have to wait 6 to 12 seconds for a transaction. So I mean, this makes it a lot more efficient to test stuff. Then you can just deploy it to the testnet once it's working. So yeah, I mean, this is how you can use, for example, Etherjs on Moonbeam. We have another question. The Docker demo looks good. Do you know if Truffle Ganache will support Moonbeam, or will Docker be the best method to develop locally? So I mean, Truffle Ganache creates its own instance, like its own node, and it's I wouldn't say that if it supports Moonbeam or not, because basically it just creates its own node. I'm not even sure if it runs a get node or what, but I would say that if you really want to test Moonbeam out, I would just run the Docker instance. I mean, you wouldn't notice any difference, right? That's I would say the beauty of it. It's just like you wouldn't even notice that you're running Moonbeam and running a get node until you connect with like Polka.js and you want to like test governance features or like staking features, right? That would be like the only difference. But if you really want to try Moonbeam out, I would definitely go and try the Docker way. I would say is the easiest. But yeah, great questions. All right, so let's go to Truffle. That I know that you were wondering about the HE wallet provider. So I did prepare a Truffle folder, as you can see here on the left hand side. Hopefully this is not too small for you. And in here we have the typical Truffle config file. I can just run to Moonbeam Truffle box. Let me clear this for you. And in here I do have the typical, like Truffle config file. That you would expect, right? So I already did npm install, so I forgot to mention this. I already did npm install in all these like folders and paths. So I do have HE wallet provider here, as you can see. I'm importing my private key from the secret stuff file. And then I'm just defining the provider, right? So I'm just saying, hey, HE wallet provider, can you create a provider for me with this private key and this URL? And once again, notice that I'm running the 3.7 custom port. You can also have the Moonbase Alpha testnet provider just by setting the testnet here, as you can see. And we also have, you can have, once again, an Ethereum. So let's say you're a project and you have your Truffle config file set up with an Ethereum provider, and then you can just add this line to your project, and that's it. Like in 5 to 10 seconds, you have everything ready to deploy to the testnet. It's just like that simple, really. And let's go to Hardhat, because I think the example that we'll do in Hardhat is a little bit more exciting, honestly. In the Hardhat example, what we have, let me see, this is correct. In the Hardhat example, what I prepared is a contract, okay? So it's a little bit like a tongue twister. So basically, there are two contracts. This is the number store contract and the incrementer contract, right? So in the number stored contract, we have a value that I called number stored. And basically what we're going to do is that we're going to use this incrementer contract to increase that value by 1, okay? So this is just like a fun example of a contract calling another contract. And you can see that in order to do so, the number stored contract provides this increment number function, okay? So basically what we're going to do is that I have two script preparers, but if you're not familiar with Hardhat, it's super similar to Truffle, and it just provides like a way of like deploying contracts to different testnets and so on. So for Hardhat, you need to have this Hardhat ethers. For me, it's like the best way to interact with using Hardhat. And then I just imported the private key here, as you can see, and I do have this standalone running with the 9937, once again, custom stuff here, and the private key that I import from the secret stuff. Once again, you can just just deploy to the testnet using this provider instead of a standalone node. So what I'm going to do is that I'm going to go ahead and run npx hardhat run, and then I have to specify the network, which in my case is going to be dev, and then I have to say the script that I want to do. So in my case, it's going to be the deploy contracts, okay? So in here, you see that I got deploy an incrementer contract, I got this address, and then I got I deployed the number stored address. But you might have noticed something. So in the number stored contract, the constructor function needed an address, right? So if we go to the deployed contract scripts, this might look a little bit like overpopulated, but we'll go a little bit like line by line, right? So right here, what we're doing is that we are getting an instance of the incrementer contract, okay? And then we're gonna call the deploy method of that instance to deploy the contract, to initiate the contract. And we'll just wait until it's deployed, right? And then what I'm doing is that I'm repeating the same steps as before, but with the number stored contracts. But when I call the deploy method, I'm passing in the incrementer address. All right. So this way, the number contract, the number store contract, has already the address of the incrementer contract to interact with it. Down here, what I did is just to define a JSON object, and then just write it to an addresses.json file. And the idea is that in here, you can see that I have both contract addresses that this other file will use to interact with the contract. So interacting with the contract is fairly simple with Hardhat. We once again we need to fetch the instance of the number store contract, and then we can just run the attach method, passing in the address of that number store contract. That way, this initiation of the contract knows that it's going to interact with this address, right? And we can just basically see, we can just call the fetch number. To fetch the number, we're just going to call the number stored method of that number contract. And I'll just log it down here, as you can see on line 13. Then we're going to increment that number by calling the increment function of that number contract. So if we recall, that first contract up here had this incrementer number function, right? So now what I'll do is that I'll wait for that transaction to be successful, and I'll fetch the number again, all right? So what we can do now is run the same command as before, but instead of the deploy contract script, I can just go to interact with contracts, right? And you can see that the current number was stored was 0, now it incremented it, and then now it's 1. And I can just keep running this over and over, because it's interacting with my contract. All right. And yeah, that's it. I'm really sad that the truffle box example did not work. I'm pretty puzzled by that. I'll just try to give it a look after the presentation. I don't know if I did something weird here. No. Oops. No, I did something weird. So yeah, I'm pretty puzzled about why it did not work. But I'll make sure that it's working in the GitHub repository that I shared. And make sure that it's working for you guys when you test it out. So we have a question from Angela. So how does the gas mechanism, price mechanism work? I got it how it calculates gas costs similar to Ethereum, but what governs the gas price? Is it going to behave similar to Ethereum gas price? Yeah, this is a great question, Angela. So basically, right now, actually nothing governs the gas price of Ethereum, right? It's just like a free market. And people are just more or less willing to pay more to get their transaction processed when the network, the problem what happens is that when the network's clogged up, it's full, people are willing to pay more to get that transaction, make sure that transaction is included, so it's successful, right? So it's just basically a problem of the capacity of the net that the network has that has made the gas prices so high. So we do expect to tackle this issue by providing more gas per block and a faster block time. But it's basically a question of the free market. It's just I would say a free market thing that governs the Ethereum gas price right now. So yeah, hopefully that answers your question. All right, guys. Well, it has been a fast and journey throughout all the slides and examples. I do have one more slide. Basically, make sure that if you want to test everything that I just did on the testnet, go to our documentation side on the Getting Started testnet, connect, and you will here find the HTTP endpoint, the WebSocket endpoint, and how you can configure Web3 and Etherjs to connect to the testnet. Okay. And yeah, before I finish this first workshop, how you can get in touch with us. So there's the Moonbeam.network website, the Moonbeam Foundation website as well. We're very open and friendly in Discord, and make sure to join the Discord channel and ask any questions that you have there. We're always happy to answer you guys. Feel free to go to the documentation website and make sure that you can dig throughout all the tutorials that we have done, and also a link to our couple of GitHub repos there that we're actively working on. We are hiring, so yeah, if you're interested in working in a crypto company, you have some knowledge in Ethereum, and you're like a developer, we do have some positions open. So make sure to check them out in the link shared in the bottom of the slide. And yeah, thanks a lot for tuning in for this workshop session. It's truly exciting. The idea is to have a monthly session. We hope to have really great guests. They can share ideas about their projects and integrations they have done in Moonbeam. So thanks a lot for tuning in. And yeah, we'll see you in the next workshop in a month's time. Thanks a lot once again. Happy to be here.